Hey everybody, welcome to the 5th episode of the Mr.Prototype and Co. podcast, where we are going to discuss everything about creating products, making prototypes of course, and much more. Today, we're at home. It's just it has been holidays here, we are taking it a little bit easier this month with all this jazz.
It's a time of the year for that.
Yeah. So you will see the cat. If you are watching this on YouTube, you will see the cat going around. You might hear the dog going and coming. What are we going to talk about today?
It depends a lot on why you want your prototype. If you want your prototype just to validate that an idea works, it makes sense to make the prototype as simple as possible. And the thing is that prototyping techniques typically give you much more flexibility in terms of what you can do. For example, 3D printing is even though it uses the same plastics in some cases as injection molding, it gives you much more flexibility. You can make shapes that you can simply not make with injection molding. But if it's purely to test if something can work, then this has no issue. It's fine.
Yep. However, designing for prototyping, we do it the way that fits well for our machines and for the way we produce.
Yeah.
When we get a new prototype or a new project, we see how we can fit it within our expertise, because it is what we do. Of course, if we can't do it, we will send you to somebody else that can help you.
Yeah.
But we make it to be able to be made by us. However, it's not the same model as the one for injection molding. Injection molding has some limitations. Can you tell us some?
Yeah, it doesn't matter if it's injection molding or another technique, but each technique has its limitations, including 3D printing. And what happens is that there is just different drivers at work. When you are trying to manufacture a product, the typical driver is cost. You want to produce the product as cheap as possible with a quality that is acceptable. And typically that means going to larger quantities, because mass manufacturing simply means that the larger quantity you do, the more the price goes down. There is reasons why that is interesting and why it seems very appealing on a spreadsheet often, and yet we often suggest to go with producing small series first.
Yeah, we already discussed about it in a previous episode. Why should you test your idea before going for the big time manufacturing?
Mm-hmm. But also on top of that, it will save you on designing costs during a phase in which cost is important in the development phase, and where you're unsure if the feature set is correct, if the product has all the little nooks and crannies figured out. It's cheap to iterate with 3D printing. It's cheap to change things. The model for a proper injection molded part also needs some iterations typically that you need to go through with the injection molder. And that can be costly because it has much stricter requirements, like wall thickness, like release angles, potential slides in the mold, shrinkage that you get afterwards, a bunch of things. And that is true whether it's for injection molding or, for example, for laser cutting and bending or all kinds of things.
Which techniques are the most popular? Because maybe we know about them, but our listeners, viewers won't know about the most popular techniques to make things.
Well, I think almost everybody knows injection molding from the McDonald's plastics.
Or from almost every plastic or small figurines,
almost
the toys.
Every consumer product has injection molding, and the reason is simple. You make a mold once, and then the part cost is basically the cycle time and the material cost.
What is cycle time?
Cycle time is how long it takes for the machine to make it, and with an injection molder it is typically measured in seconds rather than hours with the 3D printer. So you can, even though 3D printers are cheaper than injection molders, you can see the difference there quite rapidly, because seconds is a whole different scale of magnitude. Sheet metal bending is also really popular, especially in industrial applications.
Easily to explainable. You take a sheet of metal and you have special machines that bend it and cut it at the same time in a specific...
First cutting, I meant in there.
Yeah, of course. Or, yeah, first you cut
Yeah.
normally and then you bend. But the great thing is that it can be quite cheap
Yeah.
per unit. The bad thing is that it has a lot of limitations because it's like...
You need to be able to unfold it. It's origami.
Yeah, it's quite simple, the shapes that you can do. But where can we find it easily?
Kitchens.
Where?
Industrial kitchen at least.
Yeah, no, but even the hoods, for example,
yeah,
the metal hoods
the metal
that
hoods
are
of a
bended.
kitchen are typically sheeted or bended.
And now
Computer cases are bent, but they're not bent in the same way.
But it's close enough for you to have an idea. Now that we are talking about kitchen, another important way of working is the press.
Yeah.
For example, all the pots,
Pans.
those
everything.
are press normally.
And
Even
those can
cutlery.
be quite expensive simply because when you start to go to metal pressing, the machines and tooling required gets expensive, very expensive. So typically it's not a common process that we use with our clients.
No, it's actually just I thought of it because of the kitchen
But
and I remembered.
It's definitely also possible, also has its limitations, but it's also more of a specialist trait. And that's, again, the big thing here is how many units are you gonna make? If you make 5 units of something or 300 units or 500 units, we're talking about small quantities. Large quantities in manufacturing, we're talking about 10,000 or more. Then it's starting to be worthy to do the big molding and, for example, techniques like pressing, although that can be even higher. And you also have metal injection molding or casting, all kinds of techniques.
Cast iron pans are casted, of course.
Yeah.
It's basically you melt the metal and you pour it in a mold.
Typically what happens with these techniques is that the more units you make, the larger your initial investment can be, and because of that, the lower unit cost you can get. Because often pressed metal parts can be really cheap, because you just take a single sheet of metal and out comes a fully formed. I mean, not necessarily fully formed because you can need certain stages, multiple stages, but you get a part and sheet metal is incredibly cheap and it comes in rolls and the machine can just run for days. But you need to be able to let the machine run for days. If you're gonna have all the parts you need in an hour, you're still gonna need a week to set that machine up. So that doesn't pay back. So that's some of the biggest differences, and depending on which techniques you choose, depending on the quantity, we make a model that is suited for that technique.
Yeah. Even if you know it from the beginning, or we can assess you which technique is best for your product, we can design from the beginning thinking on that. How can it be made? Which will save us a lot of time if we need to think for production and also for prototyping. We can do both kind of at the same time. It can save you money because you don't need to redo work.
Yeah.
And will make sense because even though injection molding or other techniques might seem to be amazing that you can do everything, not everything is possible. It has limitations. We haven't talked, for example, about rotomolding, which is another that I like for some things, mostly for big pieces of plastic.
Yeah.
You just dump the plastic into a big container with the shape of what you want to do, and then you shake it. That way you get a lot of the, for example, containers. It's basically big containers.
A lot of road markers you get, like that. Like the poles. Cones not necessarily, but like the poles that you have to mark like a line.
Yeah,
the big yellow ones, or
or even the bottles. I mean, the bottles of bleach is blow.
No, those are blow molding.
Those are blow molding.
Blow molding is not a technique. Rotomolding you don't see that often because it's still quite expensive to do, because each part needs to go to the mold needs to go to an oven, needs to stay there for a while. It's not a particularly quick technique. But it allows you to make shapes that otherwise are quite difficult to make because you get hollow shapes. And now we're basically discussing techniques in detail, but that is what we would do with you if you come to us with your project, because no technique is perfect for everything. And we typically have the two phases of trying to prototype your thing, and then design for manufacturing. But until we get to that manufacturing, we will be asking a lot of questions of requirements and all the details that you can imagine to be able to choose for you which process will turn out the cheapest. Because that's eventually what is going to make your business either succeed or fail. The price.
Yeah. No, and also how easily is makeable and yeah. But everything
whether
goes
you need
around
to go
price.
to China, whether you need to stay in Europe, it all depends.
Everything depends on the production method, the amount of units, and also the assembly time. It also does a bit.
Yep.
But yeah, we just wanted to discuss and show you a little bit about the different techniques that are out there. In the blog post about this, or in the YouTube, maybe while I'm showing the video, we'll put some clips about the machines that we have been discussing.
Yep.
That will be ideal. If you are on the podcast, maybe go to YouTube. That might make it easier.
You can see a cat and a dog.
Yeah, definitely. I mean, the dog was only the back. The cat is now here. But maybe you heard them. So, yeah. I think this was a short one, just to address small things. See you next time.
Yep.
Bye.
Hope you learned something.